Hello and welcome to Photography 101. Today's edition of Photography 101 is aimed at blowing the secrets away from high-speed photography. Yes, I have written 2 books on high-speed photography. But let me blow away some of the secrets and perhaps show you why you need to buy my books. This is a photograph taken in less than a 10,000th of a second. A bullet striking some crayons at the moment of destruction. This one is a bullet going through a playing card at the moment of destruction. This is what true high-speed photography is all about. But how is it achieved? How can you take the picture, press the shutter button at the moment of destruction? You can't. It's too fast. We're talking about things that happen in less than a 10,000th of a second. It's not possible. The human hand cannot react to the human brain in less than about a 20th of a second. So how can we achieve this? Well, it's simple. We use trickery. First of all, when we do this kind of photography, which is euphemistically called destructive materials photography, what we do is we do it in the dark. Photographers have always done things in the dark, and the reason for this is because the shutter speed required is too fast for even the fastest camera. We are talking, for those pictures, a shutter speed of 1/38,000th of a second. There is no camera on Earth that is commonly available that can take a picture in less than probably about an 8,000th of a second. It's not possible. So how do we do it? Well, the big clue is darkness. Because when it's dark, we can have the shutter open as long as we want. And those pictures were taken in a semi-dark garage, and the actual exposure time on the camera was 8 seconds. The actual exposure of the subject was 1/38,000th of a second. Well, how did I achieve that? Simple. I put the camera on a tripod and set the shutter to open for 8 seconds. Then I fired the gun at the subject. The gun was already set up aiming at the subject in a little stand. And then upon hearing the gun firing, an audio trigger combined with a delay unit fired the flash at an appropriate time. This is a flash that you could use. It's a little Vivitar 2400M. They're about $12, $13. They're not the best in the world. They'll give you an exposure of something like a 2,000th of a second, which is fine for most things. If you want to freeze bullets in flight, you might need something a bit faster. Typically, the people that do that use a micro flash, which is usually a home-built thing. I've detailed how to do that in my books. Not that I've ever done it. I have absolutely no intention of ever building a micro flash. I do wonder whether with the highest speed of LED and the high brightness LED, whether it could be done with an LED instead of 50,000 volts going through an air gap. But that's by the by. So we have the flash unit, and I like to connect my flash units to the audio trigger via a radio remote. Now, the reason I prefer to do that is just in case, particularly with the older, cheaper flashes, just in case the shoe voltage is too high. because modern digital cameras cannot take a high shoe voltage. Now this is a receiver. It's a cheap Chinese receiver. It connects to this cheap Chinese transmitter. They're both switched on, and if I press the button here, oh, needs to switch that one on. There we are. There we go. You see the red light flashing. So that takes care of the connection. It distances everything by making it a radio connection. This is the main unit. This is a delay unit combined with an audio sensor unit. And let's see, let me switch this on. You should have seen the trigger light flashing. So that is connected to the transmitter, and I actually have the wrong cable here to show you, but it is connected. There is a plug there, socket there, and then you have a hot shoe socket there. You might have to make your own connector. Don't worry, it's not hard, it's just a little bit of soldering. So we have, to recap, the gun fires. The sound activates the sound trigger. The sound trigger activates a delay unit within the trigger, or a separate delay unit, particularly if you're using the high-vis kits. Then that fires the flash. The flash lasts for a 38,000th of a second and freezes the subject. When all that is done, the shutter closes and the picture is done. Hence the pictures I just showed you. There are a whole manner of ways of doing it, a whole manner of different ways of triggering, a whole range of different triggers. This is a cheap $85 trigger from eBay. I have a more expensive trigger that's even better, but that will work for the beginner. This is probably about a $25 kit from eBay, straight from China. I think this came straight from Prague in the Czech Republic. And this is a standard Vivita cheap and nasty flash. It's a 2400M. Yes, it works. I don't recommend it because mine came faulty and I had to fix it. Not the fault of the distributor. It was just probably a badly produced one. It was made in China. Nothing against things made in China, but sometimes the quality control can be a little bit lacking. This is of course why things in China are so cheap. It's the end user that does the quality control. So we have, to recap again, we have a cable connecting the trigger to the sensor. Then we have the remote receiver connecting to the flash, like that. The flash takes the picture, bingo, you have a high-speed image. And you thought it was hard. It's not really. This handful of stuff is all you need to take high-speed pictures. That and a camera. Now, this is good for most things. It's a sound sensor only, and it's not that sensitive. It won't pick up the sound of drips. For that you need a better trigger. But there you go. High-speed photography debunked and explained. I hope to see you again in the next episode of Photography 101. In the meantime, be safe, take lots of pictures, have lots of fun, and enjoy life.